Okay, so thank you for starting the recording. Okay, hello guys. We are from the S3. I hope everyone is doing well. Uh, we are from Data Science, Statistics, and Society Student Club, and we are holding a review seminar as preparation for Stats A57 final exam. So, uh, so I'm Muhammad Anis Jubilian, you can just call me Billy. And there is also Guo Cheng, you can just call him Bob. And uh, we also have Anaki here from the S3. And yeah, okay. So now we start this review seminar. So we ha- we have this test exam from 2022, and so we have basically two data sets. The first one is superstore underscore sales.csv to cover questions 1 to 4, and we also have insurance.csv to cover for questions 5 to 6. So the and then we for the superstore underscore sales.csv, we call it the sales data here, and we want to convert the date into like a proper numeric date column. And this is the first thing that we have to do. So we want to create order underscore date column as a date in this format. Uh, sorry, you this, so we cannot share this, sorry, but we will pause the recording, so don't worry about it. And so for this one, and basically like this is like very like simple thing, but if you do it like in the beginning of your solution, it's very helpful. So the four important libraries that we have in this course is tidyverse, libradate, knitr, and ggplot2. So after loading those libraries, and then you can uh, load your data set, which is superstar underscore sales.csv, and you want to create column called this. If you have any question, just type it on the chat or you can just click. Okay. Okay. And now let's go to question 1. Can we get this yes without? Oh, sorry. I already answered that question. Okay. And okay. For the question 1, you want to recreate this table. So, okay. So you have here, you have n, which is the number of the rows for each year, and you have average, and you have IQR. So it's also explained here, the year is the year which order was placed, and the rest of the summaries are the for sales variable. And you want to get the IQR, which is the difference between 75 quantile and 25 quantile. So, so if you have summary of sales, hopefully I'm still okay. Okay. So you have this. So you have the sales variable here, and you have the profit variable here, unit price variable, order quantity, order priority. So you want to get the average for the sales. So here. So the most important thing here, because you don't have year here, you need to add new column called year, because you want to uh, create a column year. You want to group by year, so you need to create new column called year. So anything can guess like what is the command to get Like you can just type it in the chat if you know how to create year here. Anyone can guess? I mean, I just try to be interactive as possible. Yeah, okay, so people ask if this recording will be shared to everyone. So we will post this on the DS3 YouTube channel, so you can watch it there. Okay, so since everyone doesn't answer my question, so in order to create your column, you can just create a column called year, and basically you use the year function from the library date library for the order date. And then afterwards, so you can just uh, if you see this, you have this and average and IQR. Like if you see this table like this, if you see like this table like this, then you need to always think about the summarize function. So you have group by year and then summarized by the number of rows and summarized by the average and also the interquantile. So okay, here you have this. So anyone wants to guess how to get the summarization of them? I mean, you can just type it in the chat or just speak if you want. Okay, thank you, J user, for answering it. Okay, so to create that, so you can use summarize function. So n is the number of rows, average is the mean of cells, and IQR is the quantile for this. Hopefully this thing works. Okay, so you get this. And it doesn't look fine because first, this thing, you need to group by year. So group by year, and then you need to do the summarize again, and hopefully this one looks fine. Okay, so you have this, but oh no, you don't get like exactly like what you have here. So which, like, can you guess which, what are the difference between this table and this table? Anyone can guess? No, this is not screen freeze. Oh yeah, sorry. Yeah, so my bad. So like you can see here, uh, like this thing is you have year here 29, 2009, 2010, 2011, 2012. You have the average here, you have the number of rows here and the interquantile. So like do you guys can spot any differences between this table and the table that question asked? Yeah, exactly. So you need to arrange this by using the arrange function. So anyone can guess this. So you need to put the arrange thing here. So you need to put arrange. You get this. Finally, you can get. Okay, like that. Special in this. Yeah, it's so be careful for this. You might get this error like in your exam like this. So I know this is like very painful, but yeah, that's just our things. So if you get like this kind of error that I show you here, you can just first create a data set and finally get this. So like to avoid that kind of error, create a data set, save it as a variable, and then you can just print. Hopefully it will work. Okay, it works now. So this is what you have in your question one part A. Do you have any questions for this? So it's exactly the same here. Actually, it's arranged by n. But yeah, okay. Anyone has any questions for this, or do I have permission from you to continue? Can you explain the IQR column? Okay, Liang Shu Chen. Sorry if I spell it wrong. So IQR as uh, given here, it is the difference between 75 quantile and 0.25 quantile. So you need to create quantile as this. So it's given from the question. Does it make sense for you, or are you still confused? Okay, you see. Okay, thanks. No worries. And okay, do you guys have any questions about this, or do I have your permission to continue? I believe the actual sensor. Okay, it's the quiet later. Okay. Thank you, Bob. I mean, most of people who take okay, okay, Jay. So most of people who take this course is first year, so they haven't thought about that. So it's given by Professor Shapchi. You can find this interquartile in your second year or third year statistics course. Okay, and then for the part B, you want to create a table that shows the product category with the highest total sales for each year. And this is the tricky part. Your table is supposed to have 4 rows and 2 columns. Okay, so again, if you are confused about this, suppose I don't know what is the answer for this question, but actually I know. So you want to again you want to analyze the data set, summary again of the cells, and see which one things that you are looking for. And you see this product category. What is product category? For example, you can sell and then product category. You see this, and you see like, for example, you want to see the head of this. You can just click this. And oh, it turns out like it is the category for product categories. And you have office supplies, furniture, technology, and so on. So now you want to categorize it based on the product category. So I mean, now you are acting as a data analyst. So you need to analyze your data. So because you want to group by the product category, so you need to use the group by function again, and you have this. So you have cells, and then you want to group by year and product category, and then you want to summarize it by the sum of cells as asked here. So you want to get the total cells. That's why you need the sum of the cells variable. And again, you want to arrange by year and the total cells here because you want to get for each year. So now you get this, D3. Hopefully this thing works. Okay, so you get this. But this is the tricky part. You only want to get the highest total cells for each year. So if you see this, like you already arranged by year and also the total cells, and you want to only get the highest cells for each year. So row 3, row 6, row 9, and also row 12. So you only want to get those rows. So like this is a good part for like this is a good question from Professor Shams to test your answer about the vector thinking. So in order to get that stuff, you need to put here C, yeah, and then comma, which stands for which columns that you want to get, and we want to get all columns here. So we want to get the product category on total sales and year. So basically all columns in D3. So we just leave this as default, which is the all columns thing. And we get this, which give you this 4 rows and 2 columns, 1, 2, 3, 4, 4 years and 2 columns. Is it okay to just manually pick them? Yeah, I manually pick them. Row 3, row 6, row 9, row 12. Isn't it 3 columns? Yeah, actually this one should be 3 columns. Yeah, this should be 3 columns. Yeah, you are correct. Thank you. Because you need the product category on total. If you want, you can just, for example, specify for the year and the total sales as well. So you only get this. But it's fine if you want to get this. So the year and the highest sales. Yeah, thank you for spotting the tricks. Do you have any questions for this, or do I have your permission to continue? Continue. Okay. Now let's go to question 2. Okay. After the table, question 2 is the plot. So we are TAs and also professors are assuming that you are proficient with this graph. So there is no additional information that you need to use ggplot or aesthetic or geom underscore points. So you need to figure that out by yourself. And you want to use the sales data. Okay, so now let's analyze this plot first. So you have here, so again, you need to group by the year and be careful. This year by default will be in like the numeric thing. So it will be numeric, but we want this as categorical variable. So we need to use s.vector here. And you have the total sales in the y-axis and the order date in the x-axis, which means you need to use the order date column and the sales in the y-axis. So, and remember, you need to use patch break, and then let's do Q2. Okay, so I will let you guys think first, and I will start giving you the answer here. When do we use S vector? Yeah. I will just let you guys think first, answer soon. Yeah, let's give you 15 seconds. Okay, so you want to create first, you need to mutate the things. So cells, and then you want to mutate the thing as a factor here first, because that are numerical variables, but you want that as categorical variables. So first you need to mutate the things first, and then you just need to use the ggplot y as cell. I mean, you don't need to put this. This one is for the data set. So you want to create data sets cells. And then for the column Y, it is a cells. And for the x-axis, it's order date. And you want to put the aesthetic as here. And you get exactly the same with the ask question. Can we do ask that vector when assigning color to? Of course, you can. So instead of putting this, alternatively, you can just put as that factor here, and then put that here. Yeah, it's the same thing basically. So you will get the same thing. Yeah. But like it will not give you a good legend. I mean, it's fine as a TA, we will just generously give you perfect score for this, but it's actually not exactly the same because the legend name it's x dot vector year. So but the legend here is year. So I mean it's better for you to put that things before doing the graph. So instead of this, we want this, like the legend name. What does s dot vector do? Color s vector years in the first bracket. No, sin. You cannot put the things like in the beginning. Yeah, okay. Thanks, Bob, for answering that. Can we put color? Can we put color is equal to year inside eyes? Color is equal to year. I mean, I haven't tried, but let's try. But, hmm, I don't think so. I don't think so. I don't think so. I don't think we can put color is equal to year inside the eye on the ggplot, but maybe you can try. Or maybe like as Jay said, okay, if it's the same thing, then okay, that's good. You have alternative answers. Do you guys have any questions for this question too, or do I have your permission to continue? Continue. Okay, got it. Okay, so that's the end of the week 1, week 2, week 3, week 4. So, and little bit week 5 maybe. So now we are going to do some technical stuff. So that's the table and the uh, plot. Now we need to do the technical part. Still using the same data set cell, but now we want to compare the population level cells between years 2010 and 2011. So it's basically the population variance test or variance test. Or if you are in the a priori that you know this one is using f-test. So you want to test the equality of the variance first, and you want to use the p-value is equal to 0.05. And and then after using the variance test, you want to use t-test because you want to check the equality of two population means, and you want to use not equal as the alternative hypothesis for. But I think, yeah, we have the default thing for here, so we can try to use the default. Okay, now let's try part A here. I will just copy this so that I don't have to go back and forth. So this to this. Doesn't work. Okay. Anyone remember what is the command to do the variance test? Anyone can guess? Yeah, yeah, exactly. Just first that. But first, you need to be careful because you only want to get the 2010 and 2011. So you need to filter based on 2010 and 2011 and just use variant test. And you get that. Okay, so as I've said before, it's the F test. And you get so this is your test statistic. This is your degree of freedom. And this is your p-value. This one's not important for this course. You can just ignore this, but this is very important for this course. And you get the p-value here at 0.06752. Okay, that's a good question. I mean, if you answer like that in your final exam, J, it will be good. TAs will generously give you perfect mark for that. But actually, we want to like either uh, interpret the p-value. So it's better for you to answer as like accepting the hypothesis or rejecting the hypothesis. But it's fine, it's fine. So the like answer here is because the p-value is bigger than 0.05 because we use 0.05 here as the cutoff for the level of significance. So because this one is greater than 0.05, we fail to reject the H0. So this is based on the p-value, i.e. p-value greater than 0.05, we fail to reject the null hypothesis. Alternatively, like this is not the answer. I just give you like some uh alternative. If you find that your p-value is less than 0.05, then you said we reject the H0. So we would never accept the null hypothesis, but it's either we reject the null hypothesis if that p-value is less than 0.05, or we fail to reject the null hypothesis. Do you have any questions for this, or can I continue? Continue. Why 0.05? Use it. So you have this one. Test the equality of population variance at level of significance with cutoff 0.05. So it's given in the question. It's 0.1 in final solution. What? No, it's 0.06. What do you mean? We have the p-value is 0.06. Oh, and by the way, this is not your 2023. This is 2022. That's 2023. I'm discussing like different problems. Review seminar for 2020. I mean, this is like review seminar from DS3. So this is like different thing. I mean, this is different questions. I mean, it's also stated that the p-value cutoff is 0.05. Does it make sense, or do you still have any questions? Use it. Fisher said 0.05 in his book. Uh, so okay. That's true. Fisher true. Or the final answer solution is also true. But so we are focusing on this particular question. So we are not following Fisher's book. We are not following final answer solutions. We are just focusing on this question. And the question said the p-value cutoff is 0.05. So it's if it is less than 0.05, we reject the null hypothesis. But because this one is greater than 0.05, we fail to reject the null hypothesis. Do we need to state the confidence level is 0.05, 0.09 here? No, you don't have to, because this question doesn't ask you to do so. So just focus on your question. Do not do more than the question asks. Null hypothesis here is that, yes, you're right. So if you are confused about this, so this is your alternative hypothesis. Yeah, you're right. So the null hypothesis, it's always equal, basically. So the null hypothesis is uh, uh, variance of population in 2010 is equal to variance of, this is talking about, we are talking about cell population. Yeah, population variance. Okay, let's write this properly. Cell population variance of cells in 2000. Okay, yep. Okay, thank you, Rob. Do you guys have any questions for this, or can I continue? Yeah, please continue. Okay, let me know if you still have any question. Okay, so that's not the end of our answer. We still have this. Okay, after testing the variance, we want to check the two population mean. Okay, recall that for the population means, you have this basically. So if you want to do population, I mean it's actually proportion S, but okay, let's do it from basic. So population means you have two things. Either variance is the same, you will use the different things, or variance is different. So because in this case, we fail to reject H0, the null hypothesis. So we are assuming that the population, the variance is the same. So you need to say here, because we fail to reject the variance, so we are assuming the variance is the same. So that's why, sorry, what is the syntax cells? How is it different from cells? Cells, cells. Okay. Okay, let me know if you have any questions. Thank you both for answering the chat. Okay, so we use because we are like from the null hypothesis we fail to reject the null hypothesis, we use the t-test. So remember, if you are asked to test the two population means, you need to use t-test for this course. And then you want to use the cells 2010 and 2011, and you are putting the variance dot equal is equal to true because based on our variance test. So this is what we get. So get the p-value is 0.5968. Suppose that you doesn't do the variance test, then we get the different test statistic. So you need to be careful here because like if the variance are not the same, then the test statistic is 0.452. But if the variance is the same, then we get actually very similar. So in this case, it's not that big. So you get this, the p-value is 0.5968. And again, if you read the question again, you use the 0.05 level of significance again. So you need to interpret this based on the 0.05 level of significance. And yeah, you fail to reject the null hypothesis again because the p-value is so big. Let's do this. Okay. The p-value suggests, i.e., p-value is bigger than 0.05. We fail to reject the null hypothesis of the equality of the two means. The significance level, what about that? How to convert from significance level to confidence level? How to convert? So, okay, okay. Okay, let me think. Okay, so you have this graph. So significance level is this, and confidence level is this. This is your confidence level. So we are talking about two-sided test, okay? So for the two-sided test, this is your confidence level or the confidence interval. So, and this is your significance, which called alpha. So it's the sum of this. So basically, Nisit is correct. So for the, like in this case, this is like the two-sided test. So confidence level is equal to 1 minus significance level in two-sided test. But if you are talking upper tail and the lower tail, it will be different. Yeah, that's true. In this case, because significance level is 0.05, and we are talking about two-sided test again. So confidence level is just 1 minus 0.05, which is 0.95. I hope that's clear for you. This is your 90% confidence interval. If it was one-sided. Okay, okay, okay. Okay, now, so is it clear for the two-sided test, or do you have any question for the two-sided test, or no? Okay, now let's talk about so for the upper tail, so for the one-sided test, we have either upper tail or lower tail. Okay, so for the upper tail, it's actually the same thing, but basically you have upper tail is 1 minus. Okay, so we don't have confidence interval for upper tail. We don't have a confidence level for lower tail, but we have, it's called rejection region. So for the upper tail, it's between, it's called the Z alpha infinity. And for the lower tail, the rejection region, it's the minus infinity and that thing. So I think you don't have to worry about that for this code. So it's fine. It's minus C. Hopefully that's clear. Yeah, that's true. Thank you, Bob. Hopefully that's clear. Does it make sense, or do you still have any questions? Do I have your permission to continue? I mean, let me know if you still have any questions. Uh, yes, thanks. Okay, okay. Do I have your permission to continue? Yeah, okay. So that's for part A. And now you have part B. Okay. You want to check the equality of the two population means by calculating a 95% bootstrap confidence interval for the difference between the mean cells for 2010 and the mean cells for 2011. So these things are actually the same thing again, but the approach are different. The first one, you just need to use the variance test, but the second one, you need to do bootstrapping. So, okay, now let's do this. Part B. So again, bootstrapping, we need to create a new function for this. Okay, so you can just, I think it's week 6. So if you go to your week 6 code, you will have this function. So this is like actually like the template function for bootstrapping provided by Professor Shams. So you can just basically use this. Okay. So the boot function here, the bootstrapping function. So put n as the number of rows using this 2010 and 2011 cells here. And you create your bootstrapping function. You basically select the sample size. So you do the sampling and then you just put this to select the rows based on this. And you basically get the difference between this, the mean for cells in 2010 and the population mean the sampling mean for 2011. So basically here, okay, let's do this one by one. Okay, now let's do this. So we have this, n is the number of rows, which is 4,138. Okay, and you select this. So you have this, and basically you have a factor of n numbers, and you use replacement is equal to true. So this is like very important part for bootstrapping. You create this with replacement. So you have this, basically this is lot. So do head of row of select. Okay. So you randomly sample n numbers from 1 to 4,138. You select for 4,138 numbers with replacement, and you get this. And you want to choose those rows. And finally, you do the mean difference between 2010 and 2011. So that's what this function do. I hope this clear. If this is doesn't clear, just let me know, okay? So you create this function, and you have this function in your environment here. If you see here, you have this function, boot underscore function, and then you do the bootstrapping. So I will just do it quickly here. So, okay. So you want to replicate this thing 1,000 times or 10,000 times, it's up to you. But we give you like at least 1,000 so that your uh sampling will approach the population, the normal variable using the CLT, central limit theorem. So you replicate this 1,000 times, and you get the basically this the Z 2.5 and 975, and you basically get it will take times. Okay, so why we are using 0.025 and why are we using 0.975 here? Because this is again, this is a two-sided test, and basically this one, it is 5%. So the significance level is 5%. So it means these things, so this and this, it is 5%. So because this thing is symmetric, so which means this thing is 2.5%, which is this 2.5%. And so this is 2.5%. This is 95% because this one is, if you sum this, you need to get 100. So you already had 5% for the sum of those two shaded areas. They are 5%. So this non-shaded area will be 95% because 100 subtract by 5%, which is 95%. So you get this 2.5% and you get this 95%. 2.5 plus 95 is 97.5. Sorry, my bad. So subtract this. So you get this 97.5. That's why you have this 0.975 here. So that's how you get this number. Does it clear, or do you guys have any question for this? Did it make sense for you? Or, I mean, let me know if you still have any question. Is it clear? Does it make sense? Do I have your permission from you to continue? If it is asked to test to do t-test on bootstrap means uh uh I do not understand your question appropriately, but if if I understand you correctly, so you asked about t-test on bootstrap name. So this is bootstrapping. We cannot do t-test for this. So t-test it's only for the data set. This is bootstrapping. So you cannot do t-test on the bootstrapping. Okay. So if you go back to the question again, the question asks you to annotate. My drawing. Okay. So you want to do the bootstrapping. It's impossible if the question asks you to do t-test. You want to do the 95% bootstrap confidence interval. So like I've drawn before, that 195%, so the quantile should be 1.95, sorry, 1 minus 0.95 divided by 2, which is 0.025, and 1 plus 0. So like if you want to do algebra, then you can put this 0 plus 0. So this is how I get this number over 2, and which is equal to 0.025, and 1 plus 0.95 over 2, which is 0.7. So it's 1 plus confidence level over 2, and so this is so this. So this is like if you want to do algebra. Does it make sense? Do I have your permission to continue, or do you still have any questions for this? Do I have your permission to continue? Yes. Okay. Now let's do question 4. So that's for part A and part B, question 3. And guys, you have like you have 3 hours. So this is like not hard final exam. Okay. Okay, now let's do question 4. So it's still using the self data set, and you want to compare the proportion of order. Okay, this is like an important thing. Proportion, it means the question will ask you to do the proportion test. And you want to use the profit variable, okay, between the years 2010 and 2011. And remember, now you are a data scientist using R. So you need to analyze the data set again. So what is profit variable here? So if you see the data set again, and you have this variable profit, it's a numerical data set, and you can see some kind of uh, picture what is the sales profit thing has. So it's basically this. It might be negative. So be careful about this. It might be negative, but the question asks you to do profit greater than zero. So the first thing that you need to do here is you need to filter the profit that are greater than zero. Okay? And you want to do appropriate test. So Professor Shams doesn't give you the what test you need to do, but this is the keyword proportion. So you need to do proportion test to check the accuracy of two proportions. And this one, what conclusion do you make? So he doesn't give you what is the significance level. Okay, now let's do question 8. This question worth 77 points. So this is an important question. So remember to do page break. The question 4. Okay, let's copy paste this question first. Okay. So first, you need to do the filtering. Anyone remember how to do that? Okay, since everyone doesn't remember it, so okay, let's just give you the solution. So from the 2010 and 2011 dataset, first you need to create new variable called new profit to get, so because here if you see the here if you see the question, you want to find the proportion that resulted in profit. So you want to test the population, you want to test profit that are greater than zero and less than zero. So first, you need to create a factor categorical variable which is 1 or 0. So that's why we need to use numeric as dot numeric to get. So this one will get 1 or 0 if profit greater than 0, then uh, new profit is equal to 1, and if profit less than 0, less than or equal to 0, then new profit is equal to 0. So that's what that new profit column means. And then you want to do the summarization again because you want to do per year, right? You want to do for year 2010 and 2011, and you need to use the summarize function. And also be careful here. Do you know what is missing from here? So it's very painful. And you need to do the close bracket. Be careful for this. This is very painful, but it happens a lot, actually. And then you want to do the proportion test. So here, just do the proportion test. Because what is X basically do? What does X do here? So it's basically all the variables, all the rows, all the entries that have profit greater than 0. So it's basically the sum here. And you want to do proportion test. And if you do the proportion test, the first one is your, uh, let's say, your one variable. And the second parameter, it's your number of rows here. Okay, so now let's do this. And let's say you want to check what is the D underscore profit here. So this is what we have. So this is the D underscore profit, which is basically just year, and then X, it's the number of rows that have profit greater than 0, and N is the number of rows here. So that is what is N, what is X here. Okay, so now we have this proportion test, and again, we have the p-value greater than 0.05. Do you guys remember? Because the p-value is greater than 0.05, what will we do about this? Anyone can guess? Yes, exactly. This p-value suggests that we will fail to reject the null hypothesis. Thank you. The p-value suggests, i.e., p-value greater than 0.05, we fail to reject the null hypothesis. Of, you need to say what are you testing the two proportion. Okay, here. Do you guys have any questions for this? Do I have your permission to continue? I mean, yeah, if you want to uh, like understand this, I'll have give you time. Why do we group by year? Because resulted in a profit between the years 2010 and 2011. Because we have this one. Because we have this line between the years 2010 and 2011. Okay, thanks. No worries. Do I have your permission to continue, or let me know if you still have any question? Continue. Okay. Now that's for part A. How about part B? You need to do permutation test. So this is very technical question again. And this, you have this, sorry. So you have 0.05 as level of significance. So it's given by the question. You don't need to remember if it is greater than 0.05 or less than 0.1, then that's weak evidence. You don't have to remember that. The question will give you information about that. So you don't have to worry about that. Okay, now let's do part B. You want to do permutation test for the equality of the two proportions. Ready? Let's do this. Copy this so that I don't have to go back and forth. So this, okay, you want to do permutation test. Where will the video be posted? The video will be posted on the YouTube channel, DS YouTube channel. Anaki will take care of that. Alright, thanks. No worries. Okay, we have this. So anyone remembers what is the permutation test? What should we do about that? Okay, so this. So this is a template again from your lecture. I think week 8, week 9, or week 10, between those weeks. So first you need to create your observation difference, which is the 2010. So first you need to do the observation difference for 2010 and 2011. So first you need to do, and then you create your permutation function. So this is your data set. You need to put this by year. So you take the things and you find the difference between this year is equal to 2010 and 2011. And then you again replicate this 1000 times. Again, this is a template from Professor Shop. You don't have to remember this. You just need to copy paste this code from the program. And the important part for this is you need to know which week is permutation test, which lecture discuss about uh this proportion test. So you don't have to remember all of this. You just need to know the position about which one is which material is that week. So here you create that permutation function, you replicate this 1000 times, and you need to check the equality of the proportions. So what you need to do is find the mean of this. So because this is the two-sided test. Sorry. Yes, because this is the two-sided test, so you need to put the absolute value for this. But I think we will just be generous for this. So this is what you get. And this is your p-value. So you need to sorry about that. So this is your p-value of those two-sided tests, and we have this. This is your p-value, and a high p-value, i.e. this p-value greater than 0.05, we fail to reject the null hypothesis again. So that's for your question 3 part. You just copy this file. You don't have to understand the permutation test because that's upper year statistics course. And this is, but you need to know this one is p-value, how you get this p-value. And you need to know because this one is greater than 0.05, you will fail to reject the null hypothesis. Does it matter which year we write first for this? Uh, it doesn't matter actually, but you need to be consistent for the observation difference and the diff. So if you want to put 2011 here first, for example, this one, then you also need to put here 2011 and 2 and 10. Yeah. Because again, we are talking about the equality of two proportions. So this is a two-sided test. Because this is a two-sided test, that which year first, which year later, it's not important, but you need to be consistent here. And I don't think he will ask about the one-sided test. So in case of two-sided test, it will not be important. Yeah. So you need to be consistent for line 131 and 136. It doesn't matter. Does it make sense? Does it answer your question? Yes, thanks. Okay, so that's from me for question 1 to 4. I mean, you can continue both.
All right. Before we continue, I think it's worth taking maybe a 5 minute break, and then in 5 minutes, so 8:25 is when we'll come back. I'll go over questions 5 and 6, which go over ordinary linear models and general linear models, which are the last two portions that are in this that are in this practice exam. So yeah,
Okay.
5 minute break. We'll come back 8:25, and I'll start from there. So I'm going to be going over questions 5 and 6, which use the insurance data set. So like first things first, it's worth looking over what the insurance data set is. So this is it. It's a bit hard to look at, but it's just a CSV file and it holds essentially actually before I start, can I make sure, can everyone hear me? Like, can people hear me? Can they see my screen? Is everything good? Yep. Good. Yes. All right. Perfect. So yeah, the insurance data set, essentially each record is information about some customer and then what their insurance charge is. So the first thing we're going to have to do, of course, is we're going to have to read in this data. It's a CSV file. Now, it's worth mentioning here that the library you guys are using, Tidyverse is probably like the bread and butter R library that appears in almost every stats course. And for those of you who are going to be using R in the future for whatever reason, you're probably going to be working with Tidyverse. It's a package, or it's like a grouping of a ton of different packages. So it's worth getting familiar with it. But yeah, so let's first read our insurance CSV file. I believe it's called insurance.csv. And then let's see if that's good. Insurance. Is that right for everything? Yes. Okay. So yeah, this is probably a nicer view for what insurance looks like. So it's age, gender, body mass index, children, smoker, region, and the insurance charges. So question 5, part A, is asking us to fit a linear regression model with charges as the response variable and all the rest of the variables as independent variables x, and then to interpret the coefficients for age and sex. So firstly, let's fit our model. So let's say our fit model here is, now we're going to be using the linear model function. So that is just LM. And I believe when Billy was talking, someone asked a question about the curly brackets versus the dollar sign. And this is where it's for. You'll see that the linear model function at the top here, it's taking in a formula and the data and a bunch of other stuff that we don't need to bother with. So the formula here, we want the charges. So charges as a function of age plus sex plus BMI plus children plus smoker plus region. And then I believe this is, I don't think it's optional. I think you do have to write this down. The data is coming from the insurance data frame that we just wrote down here. So if we fit this model, and then we want to see the coefficients, the cleanest way to see the coefficients is to do summary and then put in the model we just fit. If I run this, here we see it. Now, this is our linear model, and these are all the coefficients it fits. So for those of you who want some more practice of fitting or reading what the linear model is, basically, can everyone see my writing? This here, these are our estimated betas. Uh, yeah, these are our estimated betas. This is our our standard error is right next to it, which is something we don't really have to bother with right now. Our t-value and our p-value. This p-value here, this will become important in later questions. But for now, this is our fully fit model. And we want to interpret, like the question asked us, interpret the coefficients corresponding to age and sex. So, can anyone tell me what the coefficient for age means? Right. We say we have an estimated coefficient, oops, for age equal to 256.9. So can anyone tell me what that means? Just in the chat, or if not, I can go ahead. Slope. Slope, yes, but I need a little bit more. Yeah. So Gia has it. Age increases by 1, then the charge increases by 256.9. So that is the definition of slope. Neon is not wrong. But I think for the context of these questions, do you want the answers to be in the form of whatever, excuse me, of whatever data you're looking at? So one other important thing that's missing here is that we hold all other variables, so all other explanatory variables, as fixed. Yeah, so assuming everything else is constant, so the gender, BMI, children, smoker, region, all that stuff, assuming that isn't changing, our model estimates, remember these aren't exact, we're estimating an increase in charge by about $256.90 for every year increase in age. I'm gonna make that a bullet point. Now, similarly, can someone tell me what the interpretation is for sex? Now, I need to bring it to your attention here that sex is not just labeled sex, it's sex male. So what does this mean? Uh, anyone? If no one has the answer, I can go ahead. Male equals 1. Uh, identified as male, 1. Yeah. So the thing that I think is very helpful to understand when you're fitting linear models with categorical variables is that, and this is the way that R and really theoretically you treat theoretical variables, yeah, you identify something as a baseline, and the baseline is always whatever doesn't appear in your model. So, for example, for sex, we know that it's male or female. But we notice that the coefficient for male appears in the model. And so what that means is that the X here is actually an indicator variable. I believe a few people mentioned it. Yeah, Neon and Seba both mentioned it. And so if the sex is male, then we assume we are affected by this coefficient. And if the sex is female, then we assume this coefficient has no effect, which means that when X equals 0, we are assuming our baseline is our female. So if everything else is fixed, our model estimates that males have estimated about $131.30 lower charge than female. So this is compared to the baseline, compared to the females. And honestly, this is it. This is this is part 5A. So this is our solution, actually. Does anyone have any questions for 5A? No? All right. Oh, do you have to add holding everything constant? Yes, because if you're moving other thing like the holding other explanatory variables as fixed it's a very important thing that I think you might lose a point on your exam if you fail to mention it. Because if you're moving these other things around, like let's say we were interpreting age, if everything else was also moving, then we would not be seeing changes just by 256.9. We might also see this, or we might also see a change of this, or it makes it way more complicated. And then you might have to deal with things like covariance. It's a huge pain, but yeah. For the sex interpretation as well, yeah, we have to mention for all interpretations. Whenever we interpret any coefficient, all the others are assumed to be held constant. And if they aren't held constant, then they wouldn't be that. So yeah, that's a good question. Can you explain again the sex male coefficient interpretation? Sure. So our coefficient for sex male is negative 131.3. This means that, oh, okay. Yeah, this means that because we only see male here and we observe both male and female in our data, it means female is our baseline category, which means that everything related to gender is being compared to female as a baseline category. That means that sex male here means compared to females, males, we estimate the value to go down by 131.3. So because charges here is a price, we say that males have an estimated $131.3 lower charge than female. Yeah. Will we be tested on animations using ggplot? Probably not. I would assume not. Billy would be the best one to answer this, but I would assume not.
No, no, no. You
Okay.
will not be tested.
Okay. Okay. Now on to part B.
There is there is a little chance possibility that you will be tested to use animations, but you don't have to print that. You just need to write the code, but you don't have. I mean, you are not allowed to print that because like it will print like hundreds of pages. So
Yeah.
yeah, it will be error on code mark.
Yeah. I think the way that your online exams will work is you'll probably have to submit both an R code and a PDF file. And if you do that, your PDF file is basically illegible. So chances are low. Do you know if we have access to the midterm cheat sheet? I assume so. Billy, do you know?
Yeah. So about that, like as I've already said in the beginning, so you will be given access to lectures, annotated lectures, and also recordings, but you will not be given access to the midterm PDF, to the final PDF, and worksheet PDF.
Okay.
Mhm.
Okay. So on to part B. It's still pertaining to the model we just fit. If you are asked to remove one of the not so important x variables, which one will you remove? Justify your answer by refitting the model without this variable and comparing the model performance to the original model with all independent variables. You do not need to do cross-validation to answer this. So first things first, I guess general test taking knowledge. If you see something like this, you probably lose points for doing cross-validation. It's asking you to do something else. But from looking at our model summary up here, is there any indication for which variable we should be dropping and why? Does anyone see anything? Sex and region. Yeah, well, yeah. Sanan is right. It's either sex or region, but sex male has the highest p-value. So what I mentioned earlier, this is the p-value, right? For those of you who don't know, this is the p-value for something called the Wald test. And the Wald test is literally, the Wald test tests if this coefficient is equal to 0 versus the alternative hypothesis that the coefficient is not equal to 0. And so obviously the higher the p-value, the less likely you are to reject this hypothesis. And so the one that has the highest p-value, which in this case is this one, is the one that is most likely to have our null hypothesis of the coefficient being equal to 0. So in this case, sex male is way bigger than any of the other ones. Region Northwest is a close second, but it's not higher and we're only being asked to drop one variable. So using this p-value, we assume that the least significant variable here is the gender. And so we try to remove it in our next model. So going off of that, I don't know if I can scroll up or down with this. Will it stay? No, it won't. Okay, so let's just erase this. There you go. So knowing that, let's fit a model without gender. So for ease, I'm just going to copy and paste it over. Oh my God. For ease, I'm just going to copy and paste it over. So we'll do our fit2. Fit2 is this, but now we don't care about gender. So we remove that. So now we're just doing age, BMI, children, smoker, region, and data. And we can do fit2. We can do the summary. Fit2. All right, this is our summary. Now, the next thing we have to do, now that we've refitted the model without this variable, we compare the model performance to the original with all independent variables. So, do we see any indicator for model performance? Can anyone point out to me what it is? The R squared? Yep. So it's down here, the multiple R squared here. This in your lecture notes, I believe is just called R squared. It's your coefficient of determination. And it's exactly this value. Now, I don't recall if this is adjusted or not. Oh, no, the adjusted's right there. So yeah, the R squared from your lecture notes, it directly means the percentage of variation in Y that is explained by this model, or basically how much of the data we are explaining with our model. So with our fit2, we are explaining 75.09% from fit2. Now, if I were to erase this for now and then scroll up, what does the R2 for this one look like? It just so happens actually that the gender had such a low significance that even though we're looking at fit1 now, the R squared is the same. So fit1 also explains, oh God, also explains 75.09%. Now, I should give a disclaimer here. These are not the exact same values. Like, I know it says the same here, but it's very likely that when you have something like this is an incredibly high p-value. When you have a p-value that is this high, you might see a variable that is so insignificant that removing it removes like from your R squared removes like 0.0001. And so it wouldn't show up on anything that's rounded to 4 decimal places. So it says same here, but you should be scared of using the word exact. You can say negligibly different or like almost the same. I see a Q&A here. I had a question about the past final of 2023, and that it says, test the value of P at level of significance 0.1. Does it mean we round the value of P to the decimal place or check if it's greater than 0.1? This is from Sohail. It's in the Q&A section. When you test at a significance of 0.1, so then using the markup. When you test at a significance of 0.1, it means you're comparing your p-value to 0.1. So if our significance level is 0.1, then we reject H naught, which is our null hypothesis, if our p-value is less than 0.1. So you're not doing any rounding. You're just checking that your p-value is less than 0.1. And this is where your significance level comes in. Does that make sense? Even though the change is so small, would you choose to fit one or fit two? Okay, so Seba brings up a good point here, where the change in quality of our model is so incredibly small that, yeah, exactly, that we don't, like, the models perform the same, basically. So in a case like this, we always choose the model that has least variables because, from a computer standpoint, it's more efficient to run something with less variables. There's less calculation that has to be done. And this is formalized, I believe, in your later stats courses with something called the information criterion, which takes into account how many variables are in your model and how good of a fit it is. So I think it's something like minimizing the error plus two times the number of variables in your model or something like that. But yeah, it's exactly what Sanan described, where you're trying to balance how good your model is while also fitting as less or the least number of variables. But yeah, so we confirmed that the gender is least significant variable. We removed it, refitted our model, and we see that the performance of the model basically hasn't changed at all. Yep. And that is honestly all of question five. Question five, I think, is probably the simplest question in your exam. It's a lot of the linear modeling questions is just reading. Like you look at the summary and you read it. I don't think there's too much different there. The one thing you guys need to look out for is just where what information is. You need to know your p-value is this column, your coefficients are this column, where to find your r squared, all that kind of stuff. But yeah, does anyone have any questions about question five? Do we need to import all the libraries manually in the final? Yes. It's good habit, just always have the libraries at the top. Yeah. I think I'm actually missing one or two. There's one for R rock or for rock that I will import later. So we also need a library P rock, I believe. And these are case sensitive. So yeah, P rock, there you go. So yeah, you need to import all your libraries manually. When you're doing your exam, I think you're taking it in the computer lab. So the computer lab will have all the packages installed. You can just run this at the top and it will be fine. All right. On to question six. Suppose we want to model the probability of incurring a significant charge, which is defined as the charges. I see this popped up. Okay. Which is defined as the charges being more than 10,000. Part A, fit a logistic model that models the probability of incurring a significant charge as a function of age, sex, BMI, children, smoker, and region. Interpret the exponential of all the coefficients corresponding to age and sex. So, first things first, it's indicated in your question, of course, but anytime that you're modeling logistic models, your y, your response variable, is a 0 or a 1. So we don't have that here. Our charges are, they're actual numbers. So we need to actually add a column to that. So we need to modify our data here. And we're going to do that similar to what you guys did in, I think, question one or two, where we're going to say our new data frame, insurance with significance, is defined as the insurance data frame, the insurance data, I guess, but we mutate a new column on there. And that column I will call significance. And it will be, let's see if I remember this. It will be if else charges greater than 10,000. If yes, then 1, else 0. So this is the if else function. Basically, it takes in a condition and then what the value will be if it's true and what the value will be otherwise. So this should give us a new data frame. If I take a look at it, yep, anytime the charges go over 10,000, we get 1. Anytime the charges are under 10,000, or equal to, we get 0. All right, and now we can fit on this because we want this sig, this sort of Bernoulli variable, to be our response. So when we fit the model, we can do fit, I'm going to call it the logistic model, is equal to, and when you're fitting logistic models, by the way, logistic models are not linear models. Of course, by definition, they aren't. But you can't use the LM function. Is it possible to omit the if-else because that is Boolean? No, if I omit this, I will, instead of ones and zeros, I believe I get true and false. So if I remove this, oh, I gotta, yeah, let's ignore that for now. As numeric, true, false, and then if I did as dot numeric, I think as dot numeric will work. Yeah, so as dot numeric does work as well. This, however, the if else, I believe is in your lecture notes. So the example that Sharir goes over in your lecture notes uses if else. So yeah, case one also works. There's a few ways to get this to work, but I think mimicking Sharir's version, I'm going to use if else because that's just what he has in his notes. 1, 0. So yeah, it is the same. I don't think you'll lose any points for doing case when or for doing as numeric. I think you'll be fine either way. Missing a bracket here. There we go. All right, so we fit our model, and we now use the general linear model function. This is GLM, I believe, comes from tidyverse. Don't quote me on that, but GLM is not the same as linear model. And we are fitting the significance, that Bernoulli variable, as a function of age, sex, BMI, children, oh God, smoker, region. And this time, our data is the insurance with significance. So now we can do summary fit log, see what that looks like. There we go. So this does look a lot like what we saw earlier. There are a few differences. You don't get your residual or you don't get your R squareds. Instead, you just get residuals, null residual, residual deviance, all this kind of stuff. But now we are being asked to interpret the exponential of the coefficients corresponding to age and sex. So can anyone tell me what the coefficient or what these coefficients mean really for age and sex? So same as before, we need to hold all other variables as fixed. We can start with age. Can anyone tell me what age is or what the coefficient here for age is? The log odds of having the charge over everything else held con. Yeah. So that's exactly right. Age here, this coefficient is the log odds of having a significant charge if you are male. So when male equals 1, your log odds increase by this much. So oh God, the log odds of being charged a significant charge when male, or when age equals 1. When age equals 1, or when age increases by 1, increases by 0.0168554. For those of you who don't know or just need a refresher, the odds of some event E is equal to the probability of E happening over the probability of E not happening. So this odd, so here it's E is equal to, event of significant charge. Right. The odds of a significant charge, the log odds rather, increases by 0.16 or 0.016. Now, we can do something similar for male. Male here is a categorical variable. Once again, our discussion on baseline variables, female is once again our baseline. So compared to female, the log odds of being charged a significant charge as a male is 0.0249926 lower than being a female. Does anyone have questions? Am I good? All right. It does actually say interpret the exponential of the coefficients. So if that is the case, then oh, actually, this is something that's good to mention. So the log odds increase by that. So odds is often denoted, I believe, with an omega. This is the common denotion for odds. And normally you have like some event. So the log odds is quite literally this. And so if our log odds increase by some value here, right? So increase by, I'm going to say 0.016, then this is equivalent to, if we took the power, it is equivalent to doing or to doing, if we took the exponential rather, it is equivalent to saying, if you know by way of log, that the log is the actual odds is being multiplied by e to the power of 0.016. So this is what that means. There's no longer plus. Once we take out the exponent, right, log plus it becomes exponents. So this is actually the one thing that we need to add on to here is that therefore, if age increases by 1, we expect odds to increase by a multiple of e to the power of this value here. And then same here. Therefore, if age, or not age, if gender is male, we expect odds to increase by a multiple of this much, e to the power of this much, as compared to female. All right. Now, the rest of this question is, or part B is relatively simple. It's just plotting. Do we use log odds for the interpretations or log odds ratio too? I mean, do we use log odds ratio in the interpretation? You can, since it's lower. Yes, thank you. You can. I think they're equivalent. The odds ratio, yeah, I think it's equivalent. So it's fine to use both. Now, plot the ROC curve, calculate the area under its curve. They say calculate, please don't actually write out the equation to calculate it. Just use the function. He gives you the function, just use it. So for the ROC, by the way, it's worth noting we need to use the PROC library. So going back down, I believe it's something like we need to make our predictions first. P is predict. fit log, and we want to predict response variables. So type equals response. Now, if you're wondering where I'm getting this code from, this is literally copied and reinterpreted from Sharir's slides. I'm just following his format because he's going to be the one grading, him and the TAs, so I might as well. The ROC object itself is equal to ROC function of insurance, insurance sig, and then as a function of P. And then we can just use ggplot to plot it. So plot ggroc ROC object, and then we can do the color equals red, size equals, I don't know, 2, sure. So that looks like, there we go. Yep, that looks fine. That looks like an ROC curve. And then to calculate the area underneath, actually, I'll write it here so you guys can keep looking at that code. Area under the curve, we just use the area under curve function, which literally is area under curve, AUC, and we put in our rock object. So we run that, and then in the R console here, oh yeah, if you guys run something like this and you use that arrow, it's your console outputs are here, and then any graphs will appear first, so you can switch between them like this. But yeah, area under curve, 0.9319, so we can note that down. The area under the ROC curve is 0.931991, sorry. And what does this indicate? It's asking us and interpret its value. Remember, ROC is the sensitivity of the test over one specificity. This means that the closer our ROC curve is to a perfect right angle, the better our model is at finding true positives. If the curve is a perfect right angle, we see the area under the curve is equal to 1. Therefore, our area under curve is 0.9391, which is close to 1. So we can assume that our model is good at picking up true positives. Anyone have questions about part B? Oh, all right. And then final part, we're almost done. I do realize we went a little bit over time, but that's fine. Part C, for this context, we are interested in constructing a bootstrap confidence interval for the odds ratio of incurring significant charge between northeast and southeast regions. Now, this looks complicated, or at least a little bit of a hassle at first, but remember, I believe Saba actually mentioned that another interpretation for these coefficients is exactly the odds ratio. And we are lucky enough, remember, we're trying to compare, where is it, northeast and southeast. We are lucky enough that northeast doesn't appear here, which means it is our baseline for region. And so to find the odds ratio between northeast and southeast, it's actually just this value. So an equivalent statement is to do a bootstrap confidence interval for this coefficient here, the coefficient for region southeast. So let's go on with doing that. First things first, we want to make our bootstrap function. Now, Billy used his version from Sharir's slides. This is also taken from Sharir's slides. It's a little bit different. This is the one from that bootstrapping or from the logistic regression slides. So if you want to find another version of this, it's right there. But we'll just say boot function is a function, and we will define it as boot data. We're sampling from insurance sig pipeline sample n size equals number of rows of insurance sig, and then replace equals true. This replace function is very important. If you don't use this replace function, all your samples will look the same. And then we do the fit. So the bootstrap fit is the same thing we were doing earlier. We literally just take this function. This is our general linear model. And we fit it there, but instead of using the insurance, we are fitting from our boot data. And then we want to return the coefficient. So we can do coefficient of our model, which is called boot fit. And we want to return, this returns a list of all the coefficients. We want to return the coefficient that is specifically region southeast, pardon me. So this is our boot function done. And then to do the actual bootstrap, we want the confidence interval. So bootstrap, we want to replicate it. So we do, I don't know, result, I guess, is equal to the replication of that function 1,000 times. 1,000 is arbitrary, 10,000 fine, 3,000 is fine. Should be insurance sig. Thank you. Yes, it should be insurance sig instead of, yeah. Is E coefficient? No, it says odds ratio. Oh yes, it should be. It should be e to the power of the coefficient, but it's better to deal with that later because taking the well, the math for confidence intervals kind of becomes tricky if we're just going to do the coefficients immediately. So what we're going to find is the log odds ratio first. So I'm going to repeat this function 1,000 times. Now it's worth mentioning, keep this bootstrap thing and this function in its own R block and run it once because I'm going to show you what this looks like. When I run this, look how long it takes to finish. Oops, I wrote the result wrong. Table must be data frame, not double vector. What have I done? Uh-oh. Insurance. Oh, I shouldn't be sitting here. Yeah. There we go. Yeah, look, it's running. It's running. Look how long this takes to finish. And I think it's not so much like a bad practice. I think just for your exam, yeah, that took us all a few seconds. If you're doing 10,000, it's going to take way longer. But just for your exam, it's helpful to have this in its own R block so that you run it once and you don't have to run it again. That way you're not just sitting there, last 30 seconds, you're not just sitting there waiting for this function to finish. But now that we have our results, we want to look at, this is the CI for what Gia said, for the log odds ratio. And that is log CI is equal to quantile of the result. And we want the 0.025 and 0.975. I see a question has popped up. Where will the recording be posted? The recording will be posted on the Amex YouTube channel, and hopefully by midnight.
Oh, DS3. Not.
Oh, sorry, the DS3, not the Amex YouTube channel. I am part of both. I got very confused there. All right, anyway. So yeah, this is the CI for our log odds ratio. Now, to get the CI for just the odds ratio, you gotta love the vectorization of R. You can literally just do the exponent function, slap in log CI. Bingo, bango, bongo. There you go. And that looks way more like like an odds ratio than two negative values. And yeah, that is all of part C, I think. Uh, find yeah, that's all of part C, really. Anyone have any questions? You can also ask questions about the overall final, since this is the last question. No?
Oh, there is one question on Q&A. Bob, if you want to answer.
Oh, oh, I see. Uh, where is how many libraries we used? For this one, we used 3.
No,
We
it's like,
used
what is the difference between using sample and slice sample?
Oh, I didn't see that.
In the
I
Q&A, not chat.
oh, I see. I don't see it in the Q&A, but I can answer it, sure.
Okay,
Uh,
okay, okay.
I don't think there's too big of a difference. Uh, oh, here it is. I had one more question. What's the difference between sample, sample n, slice sample? I'm not sure about slice sample, but I think sample and sample n, well, I can check just by running them. Let's see here. If I were to do sample, yeah. Sample takes in x, size, replace, probability, and then sample n takes in table, size, replace. Okay, so sample n, it seems takes from a table, whereas sample, and I guess it also you can deal with weights and such, whereas sample, what I would assume take from a vector. Um, let's see here. We have 2 more questions. And I, honest to God, I don't know what slice sample is. You might have to look at the R documentation for that. When do we use type slash method equals class? I don't think you will need to do that here. When do we use family equals binomial? I think you can just use that here if you want. So if you don't mention it, I believe GLM will default to family equals binomial. So before I say that, I'm gonna check. Uh, family family equals binomial. Is that the same? I really should have looked at it before I changed it. No, it's not. Okay. Uh, that's a good question, actually. Binomial. Should I have used binomial here? Uh, Billy?
No, you don't have to.
Okay. So, you would
But
use
I mean,
fam
you can try using family equal to binomial.
because it gives a different answer, right? If I did
Oh,
family, I think I was supposed to use family equals binomial here.
oh,
Yeah.
wait, let me think. Let me think.
Yeah.
Um,
Give me one. So yeah, since it's logistic regression does imply the link function as binomial.
yeah. Right. I mean, yeah, it should be used using family equal to binomial.
Yeah. Uh, Billy, do you know what other libraries are loaded?
Yeah, so I will just give it to the chat. Wait.
Okay. So yes,
Uh,
can we use any package available in our studio? Okay, I'll answer these one at a time. First things first from Gia.
yep.
Yes, you should use family equals binomial. That's actually an error on my part. I should have used it. I just completely forgot to. Uh, when do you want to use it? Anytime you're dealing with logistic regression, you indicate that the family is binomial. For Joshua, what does set seed do? You don't need to know what set seed is. At most, you might be asked to use it, but you set seed basically it makes it so all of your random things are no longer random. They'll always give the same result. Brian will post or Billy will post libraries. Can we use any package available in R? Please do not. There's a question here that was sent to my direct messages that says, can we use any packages available in R? Please don't. Use the functions that were taught in your lectures. If you use another function that like does something faster, you will very likely lose a ton of points. Like you're supposed to use it with their functions, basically. So use only the functions that are given to you, which yeah, are tidyverse, lubridate, knitr, ggplot2, and then from question 5, you also need proc. Yeah. For the final, are we allowed to use RStudio and Jupyter Hub? Yes, you are incentivized to, because I believe you're doing it in the computer lab. The computer lab actually has RStudio pre-installed. They are the same, so I don't think it makes a difference. I think you can use both. Yeah, because you have access to Quarkus. It's up to your professor. If your professor says no, then don't. But I don't think it makes too big a difference here. There's another Q&A here. Oh, it just says thank you. Let's see. Yeah. Okay. Before we go, it's worth mentioning actually, if any of you are interested in further studies in this kind of area, uh, I guess like if you plan to do statistics in the future, all of question 5 kind of pertains to stuff you might learn in STAC33 and STAC67. So if you want to look further into that, C67 especially goes really, really in depth about linear modeling, how to interpret it, the theory behind it, how to optimize models. C33 is very much like this course. It's kind of like just basics in R and how to do certain things in R. You get more into model selection. And then if you're interested in logistic regression is part of a category of statistics called categorical data analysis, which is C51. And there's like huge deep dives into that. So if you're interested in logistic regression, logistic modeling, then C51. If you're interested in this sort of linear modeling, then C67 and then C33. But yeah, if Billy, if you have anything else you want to add, then we can end it off here.
Yeah, I mean that's all from me.
All right. Oh, I see one more question. Let's see here. I know we don't have access to worksheets and solutions, but will we be able to have access to our own previous works for worksheets and assessments
Yeah,
from the course
so
offline?
regarding the things like as Professor Shams already answered on ED discussion. So he said please clean your RStudio on the Jupyter Hub. So I don't think you can have your previous works for worksheet because like you need to make sure your Jupyter Hub is clean.
So short answer is probably no. Yeah. Yeah. Well, at least you know exactly what to study then. Just all the stuff that you don't have access to. But yeah, that's all. Oh, one more question. Yeah. Yeah, that's all. We'll end it here. Hopefully this video will be up by midnight. And good luck with your exams.